So hi everyone, my name is Uri Sarid, and I'm the CTO of a company called MuleSoft. We're actually located just a few blocks from here in San Francisco, and we've got offices actually in several places around the world, but our headquarters is here in MuleSoft. And for those of you tweeting, here are the various tweet handles. Feel free to use those. So I wanted to talk to you today about something called RAML, and specifically around APIs and the design of APIs. So I'm actually really excited about APIs in sort of a weirdly passionate way that's been increasing over the years. And I kind of wanted to share with you why it is that I'm excited, that our company is excited. It seems that the whole market is excited by APIs. I think it comes from something extraordinarily basic. Basic as in sort of the base of the brain kind of things, just kind of intuitive reactions to a few things that APIs give you. And so the first thing is I'm proud of being extremely lazy. Right? I don't like to do extra work. I think it's almost endemic to developers that we like to be lazy. I think, you know, I kind of saw it codified first in that old Perl book that basically said the lazier you are, the better of a developer you're going to be, because we all like to automate things. And so that kind of built-in laziness is a major driver for APIs, because APIs allow you to build on somebody else's work. Somebody's already done something, you don't have to reinvent it, you just use that, right? So whose work is it? So back in 2005, when we were, you know, sort of starting to get a little bit of the API hype, and mashups were all the rage, I remember getting all excited about mashups, and your options were limited pretty much to Google Maps and X, where X consisted of a set of 3 or 4 things. So it was all this excitement, but there was just nothing there to actually sink your teeth into. Well, it's been a few years, and if you just track the open APIs, they've gone through the roof. There's something like 13,000 or 14,000 open APIs out there, and that's kind of just the ones that have kind of been cataloged. So there's a huge trend here. There's actually something that you can actually go and build upon. In fact, there are lots and lots of things. It's almost becoming a problem to find the right things to build upon. Okay, so one thing is, for lazy people like me, APIs are really exciting. The other aspect is, again, kind of endemic to a developer. You like to be able to wrap a nice package around a piece of value, a service offering, and say, okay, you concentrate on the search, and you concentrate on the product, and you concentrate on the video, and I'm going to be sort of the orchestrator that kind of puts these things together, right? So you like modularity, you like things that are specialized, so you can actually put them together. And APIs give you that. Now, big enterprises, like the clients of MuleSoft, call that service-oriented architecture, and that's been around for a while, and that's great. But really, it's all about this kind of chopping things up into services and then recomposing them in interesting ways. And nowadays, there's lots of things that you can actually do that way, right? So you've got all these offerings around e-commerce and geolocation and collaboration and marketing, and this list goes on and on and on. So lots and lots of really useful services are really available for you now, and then you can put them together. Or if you're a provider, of course, you want to be one of these entries in the checklist, so you can actually deliver that value to other people, and they can find interesting new uses for what you're doing. And finally, the API economy really is big, right? So we know that it's big in the consumer world. We know that it's growing in the space of open APIs, but there's literally millions of APIs behind enterprise firewalls that are either existing now, or they're called services. They don't really have well-defined APIs on top of them, or they're being developed right now. And when we're engaging with enterprises all the time, APIs is an extremely hot topic, which is a good indication that there's a lot of business to be made there, a lot of money that's going around there, and a lot of new innovation that can come into this space. So those are kind of the reasons why I get really excited about APIs, and the market seems to be acknowledging that. Okay, so with that in mind, a little bit of history about me and kind of my run-ins with APIs over the years. So one of the companies that I was at was called eMeter. It's since been acquired by Siemens, but what eMeter did was we delivered large software packages, basically a platform, to utilities that were going through smart grid programs. So smart grid programs, you roll out millions of smart meters, and now you know every 15 minutes exactly how much electricity was consumed, how much gas was consumed. For people living, you know, pretty much anywhere, look in your backyard and you might see a smart meter there. So enterprises or utilities are getting these billions of pieces of data. They don't really know what to do with them, and eMeter built very large-scale software for handling all of that, for processing, cleaning it up, creating billing applications on it, outage applications on it. Why is that relevant? Well, here's a good way to look at eMeter. right? So eMeter is this huge rhino of software upon which we were tasked with building a consumer portal. So here's something that's supposed to somehow motivate individual people sitting in their homes to go and check up on their energy usage. And if you're anything like me, that's the last thing I want to do at night, right? To go actually to my utility website and check up on my usage really has to be a fantastic experience to even get me to consider such a thing. So how do you develop a really compelling consumer web experience on top of this behemoth of a software? Right? And the only way to actually do that is to iterate through the usability of that website really, really quickly until you kind of nail it. But how do you do that with this rhino sitting under you? So what we figured out is that when you've got this huge back office software and you're trying to put together a consumer portal, the important thing is to figure out what's that interface between them, right? What's that piece that ties together the back end and the front end? Because if you can nail down that piece, then even if the rhino isn't exactly where you want it to be, you know he'll get there. And you can kind of mock it up and build this kind of agile interface on top of that. And that's what I want to concentrate on right now. So that's a lesson. And the lesson from that kind of translated into the value of the API contract. So why do I call this thing a contract? Because it actually tells the people who rely upon your service what it is that they're going to get. And here's an analogy for that, right? So let's say that you're building a house. And you've got a bunch of builders who are going to create the really nice house on top, and you got a bunch of guys in blue overalls that are going to lay down the foundation for this thing. If you can decide what the contract is, what the interface is between them, and the guys building the house can start planning and building the house long before the foundation actually exists. And the guys who are building the foundation know what it is that they're expected to deliver, so they can actually start working in parallel, a little bit like tunneling under the English Channel. And when they actually meet together, they have a good chance of the whole thing actually working. So you cut development time at least in two, but the most important thing is that you have time for feedback on the front end, even while the back end is still being implemented. So that's really the reason why I'm going to concentrate so much on the API contract itself. It's an enabler. Okay, so before I joined MuleSoft, I ran the Nook Cloud for Barnes & Noble. So Barnes & Noble, as you know, people who make, amazingly enough, still make Nooks. You can buy these, and there's lots and lots of APIs that these Nooks rely upon to do things like e-commerce and discovery and register your preferences and save your notebook, your bookmarks and all sorts of stuff like that. Okay, so there were lots and lots of APIs involved, and one of the interesting lessons that I learned at Barnes & Noble is that it's okay to actually have layers of APIs, right? So we had very specialized APIs underneath for this kind of deep search or the recommendations or the product. And then we would have APIs on top of them that put this together and prepared the data for the Nook devices to make just a few calls and actually get the data exactly in the way that they wanted it. So layers of APIs are perfectly fine. We also ran into some real disasters, right? And a big lesson out of this is sort of don't expose your dirty laundry. So a specific example was in 2012, we implemented a new catalog. A digital catalog had all sorts of amazing things that it could do for digital media, optimized, had all sorts of business rules built inside. And at the last moment, we realized that we actually needed to build an API on top of it so that the self-publishing arm of Barnes & Noble could use that catalog. So we just put in some annotations, and out came a beautiful API. And in order to use this API, you would get a product description. That came back with 2 megabytes of XML or JSON. And then you'd have to tweak it in various ways. And then you tried to submit that 2 megabytes back, and you had no chance of that actually passing validation because it had all sorts of internal rules you had no idea about. And it became really difficult, and if they were able to use that API, they would completely tie the front end to all of that internal implementation of the catalog. Really, really bad design. Fortunately, we managed to work around that, but the lesson coming out of this is make sure your API exposes the model that you want to have out there, even if underneath it's a really messy thing. You can always fix the messy thing, but once you get consumers to latch on to that front end of it, they'll stay there for a long time. So that was a really, really valuable lesson. Okay. So with that in mind, I've been at MuleSoft, I guess, since sort of early this year. And what does MuleSoft do? How is that related to APIs? So MuleSoft is in the world of connectivity, right? We're trying to connect everything to everything. We're an integration platform with a bunch of other things on top of it. And in this world of connectivity, we kind of look at the world in the following way. So traditional enterprise, you got all this stuff sitting behind the firewall. And MuleSoft helps you connect that. You have an enterprise service bus. Sounds great. Now comes SaaS. In fact, now comes cloud, and now come devices, and now comes social, and all this other stuff that's outside the firewall. There's a lot more stuff outside your firewall than there is inside your firewall. And so even if you manage to solve the mess of connecting all the systems inside your firewall, Now you've got to connect to all the software systems that are sitting outside your firewall, it's Salesforce and Intact and all sorts of stuff like that. And then a bunch of other customers are connecting to the cloud and a bunch of partners and mobile, and this thing just becomes an unmanageable mess. And so what do we do? What does every connectivity software platform do? They put a big box in the middle, and you just connect to the box, and the box takes care of all of that kind of stuff, which works amazingly well. We call that the Anypoint platform. We have connectors. We can run this integration on the cloud. We can run this integration on premise. It works great for our customers, but we see a sort of an impending doom coming, which is that the number of things that are going on in the cloud is growing exponentially, right? So you've got not only hundreds and thousands of SaaS providers, but you've got millions and billions of devices. And all these things want to talk to each other. And the only way to get out of something like this is by starting to have some kind of uniformity around the APIs. The ways that these things connect to each other has got to become a little bit more controlled, a little bit more uniform, a little bit easier to do. And that's why we're very interested in APIs. And actually, each one of these points out there is a potential customer for us. So we need to help our customers actually build good APIs. And that's why I'm speaking to you here today. So we've got an API creation platform that I want to tell you about. But today, we're actually not speaking about MuleSoft at all. What I'd like to actually tell you about is something that we and a few of our other partners came up with that will help all of this ecosystem. So we're interested parties in this, but what I'm about to show you is completely vendor neutral. Okay, so here's my opinionated approach to API success, right? The key to an API's successful strategy, number one, delight your users, right? And actually, if you can do that, that's like 80% of the issue. If your users love the APIs that you provide, whatever you wanted to do with your APIs is much more likely to succeed. So how do you delight your users? First of all, you design for your users. Take into account how your users are going to actually end up consuming that API. And once you've designed it for them, right, then it should actually satisfy their use cases. Second thing is you're never going to get that right. So be able to iterate quickly, right? So give them an API. If it doesn't quite work, change that API, give it to them again, give that feedback, iterate quickly. There's probably one or two things to keep in mind while you're doing your iterations, just to save you time. The first is that the mental model that your users have in mind should align with your own mental model, right? So if they're thinking about e-commerce, the objects that they're thinking about, the operations that they're thinking about are e-commerce operations, and your API should actually model very cleanly to that. So a good, clean model is important. The other one is consistency. So as your API expands, if you're constantly reinventing patterns inside of that API, the cognitive complexity of that API goes up, and people are going to make mistakes, and it's going to be hard for them to actually be successful with your API. And finally, find ways of engaging them, right? So the way most people engage people with their APIs is documentation. It's the last thing that I actually want to read. I don't like reading documentation. I do it all the time. You have to have good documentation. It's really important to be able to fall back on that. But that probably shouldn't be your first strategy of engagement, is throw the book at people. Okay, so given that these are the keys, how do you absolutely delight the user? How do you get that reaction of, yeah, I finally found the API that I want to use? Okay, so it's all about that design, right? And there is, fortunately, a solution for this. So go back to user interfaces, right? There are actual humans on the other side of this, more or less. They're developers, and you have to be able to actually excite them. So what is the user experience for APIs, right? If you want to get user interface right, you look at the whole user experience. If you want to get APIs right, you look at the whole APX, the whole application programming experience, and think end-to-end about what it's like to actually engage with and consume your API. And the same kind of methodology that applies to UX can apply to APX, right? It's that same kind of iterative, agile approach. Test it, iterate, finally nail it down. Okay, so that's what we're going to do today. So I'm going to focus again on the contract. And one last thing, lest anybody think that the contract itself is not that important, just go to the tooling. So first of all, the contract really is where the consumers are touching you, right? So if these are your customers, right, this is the entry point. And in fact, it's the entry door through which all of them go, right? So unless you've got some back doors, this is the most important part, right? This is the part, they see you projected through this API. And in fact, it's how you want to be seen, right? So if you have a crappy API, they're going to see you as kind of a crappy provider. And if you've got a great API, that's the image that you're portraying. So to a large extent, your API is your brand. And there are companies out there that are succeeding today in very competitive spaces because they've put that extra effort on designing that API properly. You tend to version your API even more carefully than your code, which really means that you're putting a lot of value on that API. The question you have to ask yourself is, what is it that you're actually versioning? We'll get to that in a moment. Better interfaces do lead to better code, right? I think that's, for people who've kind of programmed against APIs, you know that's true. That's why a lot of things are interface driven. Get the interface right, and you'll be building better client applications as well as implementing it better. Finally, this is kind of interesting. By taking the effort to think through your API, it's kind of a forcing function to decide on kind of where your value add is and what are these objects and what's really your domain. It's a little bit of a sort of a psychological approach, but if you do spend a lot of time in your API, it will tend to kind of align your business in a proper way. Finally, it's the ultimate testing surface. If you're going to test your application, test it against your API, because frankly, that's how your consumers are going to consume you, right? So if it works through the interface, no matter what's happening behind, it must be right. And if it fails through the interface, it doesn't matter that unit tests or even integration tests are passing. This is how your consumers actually consume you. All right, so hopefully everybody's convinced the contract's really important. How do we specify that contract? What kind of interface do we want, right? So when we set out on kind of this little odyssey that I'm describing here, first is we wanted the APIs to be described very simply and very cleanly. Right? It kind of comes out of the love of simple, clean code. So you need to describe it cleanly. If it's very clean to describe, it might actually be very clean to design as well. And that's actually what we ended up finding out. And then finally, and this really isn't related to the kind of interface, but it's a side effect that's really good, is you find new ways of actually engaging the users once you've executed on this. So we'll see how we can solve all of these. There's two things that we definitely didn't want to do. First is, we didn't want to just generate more documentation, right? Because we don't like the experience of that. And we didn't want the interface to be locked in deep into your code through just annotations, right? It is an easy way to generate an API, but it's not an API that's designed for your users. It's an API that's a side effect of your coding style. So we're going to go interface first, API first, contract first in what I'm about to show you. So what kind of APIs? Right? So in the enterprise world, the biggest number of APIs is all around SOAP-based data. And that's fine. And there's an API contract language called WSDL you guys might be familiar with. And it is what it is. And it's sort of accepted. And whether or not you like it, it's the de facto standard. But more and more enterprises, and certainly all consumer companies, have moved towards RESTful APIs. So those are the ones that I'll be concentrating on. So what do I mean by RESTful? In fact, why am I calling it practically RESTful? Okay, so let's start with this. If you're going to have a RESTful API, the first thing is you define your nouns, the things that you deal with. And those are resources, right? In HTTP, they're the URI paths. So you decide what your resources are. And then the verbs are the HTTP methods. And those are already decided for you, right? So you're going down this kind of nicely constrained system where it's kind of laid out for you which path to follow. And then you've got metadata that comes in through the HTTP headers, both on the request and on the response. The responses themselves have status codes on them. So there's a well-defined vocabulary for whether you succeed, you failed, in what way you failed, etc. And finally, there's representations, which are basically the way that you actually represent those resources, right? Is it JSON? Is it XML? And there's lots of other things. Now, there's one other thing, right? Which if you're really going to do REST, you've got to move on to hypermedia. And hypermedia is where most enterprises will fall. So even though they're struggling really hard with the first few points, essentially, as far as I can tell, nobody out there really uses hypermedia, right? Where the data itself that comes back tells you what the next operation is and defines for you the linking relationships between these. So kind of a word here about REST, right? So if we're really going to do RESTful interfaces and obey all the constraints of REST, we will put together some kind of effectively API or interaction model, which no enterprises today use, as far as I can tell. Almost no public APIs actually have. So while that's a great goal, and I'd love for us to get there and has a ton of advantages, I don't think the world is quite ready for that. And certainly our customers are not ready for that. So when I say practically RESTful, what I mean is let's give them something that fixes the problems that they're already encountering in the top and walk the world slowly towards something that's truly RESTful. Okay. So with that in mind, what do people do today for these practically RESTful APIs? And I'll just kind of give you a little gallery of what's out there. First, the vast majority of people don't really have any way of encoding the API. They have documentation, they may have a wiki, and things of that sort. So that's like 90%, right? And a small number of them will use things like Waddle, which is the RESTful version of WSDL. So it looks like that. You can be your own judge. That's what Waddle is. A bunch of XML tells you the resource endpoints and so on and so forth in the way that you used to do with WSDL, but now for more RESTful APIs. Okay, another one is Swagger by a company called Reverb, and this one at least moves it to JSON. So you lose a lot of the weight that you had with XML, and it looks like JSON, and it's relatively readable. So you can kind of decide on your own. I'll kind of give you my opinion at the end. I just wanted to kind of walk you through a bunch of these. There's another very similar kind of thing by a company called Mashery that was recently acquired by Intel called IODocs. Very similar kind of structure. Feel free to look this up. Google has started down its own path. Google Discovery Docs are out there, and they're very much the same kind of thing. They're kind of nice because they have an API for discovering other APIs. And then the APIs themselves are described very much in the way that you'd expect. Okay, with that in mind, and there's one more. This one actually takes a different approach, which is kind of cool. There's a little company called Apiary, and they came up with something called Blueprint, which is effectively trying to nail that API contract within Markdown, effectively just Markdown, which is really nice if you're writing your documentation in Markdown, and somehow the API itself, the structure, is embedded inside of Markdown. Okay, so that's kind of what's out there. There's probably a few others. Here's our approach to this. So we worked for a while trying to actually use these in various tools and various efforts that we built. And we wanted kind of three things, if you go back to what we talked about before. We wanted to have manifest structure. You should be able to look at your API and immediately see this is the structure of my API. Okay. We also wanted to be able to capture patterns, because remember, we're trying to align the world a little bit. We're trying to get everybody to kind of say, okay, this is a collection, and this is a member, and these are my parameters, and this is how I do paging. And they don't all have to be the same, but at least have some level of patterns and be able to at least capture your own patterns, if not share them with other people. And we want it to be humanly writable, not just humanly readable, right? Because if your interface is so simple that you can actually code it yourself, you can actually type it out, then you're much more likely to actually pay attention to it instead of using some tools to auto-generate these huge APIs. The combination of those three things, we could not find that out there. And that's what we thought was actually necessary to get the kind of adoption around an API language for REST as you've gotten for SOAP-based APIs. Because today, none of these other things have any significant market share. So we wanted to at least try a little harder and see if we can come up with something better than that. And we enlisted the help of some friends and a few other companies you might know, PayPal and Intuit and a few others. And so we decided to start from scratch. And then we're saying, really? We have to start from scratch, everything, and invent everything? It turns out that we didn't actually have to start completely from scratch, because there is a format out there that's a little bit like JSON, has the same level of kind of understanding. There are parsers out there for it and so on, but it's actually designed to be humanly readable and humanly writable. And some of you may know this, it's called YAML. So YAML has been around as long as JSON. It's very well used in the Python community, in the Ruby community, a few other places. And if you look at YAML, it's got some really nice things that we can latch onto, right? So it's a well-known superset of JSON. You can put JSON inside of it. It's optimized for human readability. It's really great for hierarchies. It actually relies on white space to actually show you the hierarchies of things. It's kind of built for that. It's cruft-free, so it doesn't have all sorts of extra quotes and brackets and structures in order to encode it. They were very smart, the people who put this together, in eliminating as much of that cruft as possible. It's got a pretty broad tooling base, and it's kind of extensible, as in people have some well-defined paradigms for extending it, whereas JSON is just, there's nothing really defined for it. Broad tooling base, I guess I already said. For some reason, I repeated myself. Anyway, so we grabbed YAML, and we basically just put semantics on top of it to describe APIs. And we're calling that RAML. So RAML is the RESTful API Modeling Language. It's a new language to describe and model out RESTful APIs, or practically RESTful APIs. There's a work group, the RAML work group. And the idea here is to grab RESTful APIs and describe them as cleanly and with as manifest a structure as possible, and do it in such a way that the people who love REST for its simplicity don't get revolted by the actual API description. Okay, so with that in mind, let's see what RAML actually looks like. So let's say you were sending an email to your friend and you described a very simple API. right? This is just an API for user management. So it's got a collection of users. You can get the collection of users. You can create a new user on it. And you can address individual users by their ID. For a given user, you can get that user, you can update that user, you can delete that user, right? Pretty much CRUD operations on a collection and its members. This is what a RESTful API kind of looks like. And if you encode this in RAML, this is what it looks like. Pretty much the same thing. Because why shouldn't a computer be able to understand exactly the same kind of description that you would email to a friend of yours? But this is actually valid YAML. So this is parsable, and we can put a structure on top of it. Let's see what this actually looks like. So first thing is, you can lose a lot of these descriptions. They're pretty obvious once you know REST. You kind of use the methods over and over again. So if we lose that, and we start overlaying other pieces of REST and HTTP on it, here we've added a query parameter called name to filter out by name. Again, it's pretty readable. You just kind of look at it. The structure emerges for you. So you can do a lot with this, and I'll show you some more examples. But you can do one other thing, which is to start to capture patterns themselves and encode them in ways that allow you to reuse them. So here's an example, right? So without for a moment going into schemas, resource types, and traits, let's read this API and see if we can make sense of what it is. So you've got a collection of users. How do I know? Because its type is a collection. And it's got a schema of a user. So I know it's probably got a lot of user type objects inside of it. It happens to be secured. I can look inside for what the definition is of secured. I've just defined it up above. It's pretty obvious what it is. And the same kind of thing with a member called identified by its user ID. So you can crunch down your API definition into a very small number of lines that reuse the same patterns over and over again as long as you've captured those patterns. And those patterns, by the way, don't actually have to be inside of your API description. You can publish it out to a CDN somewhere and go point to a set of patterns or a library of patterns and say, I want a GitHub-like API, or I want a Facebook-like API, and reuse those same patterns over and over again in your own API. Let's see how that works. One thing first is just to say that you can actually grab anything that you might express in HTTP inside here. So one thing that we wanted to focus on was versioning. So you need to declare a version for your API. There's lots of good reason for doing that. You can encode that version inside of your base URL, or you don't have to, but we kind of encourage you to encode that version somewhere. There are template URIs here, pretty much to support what we saw before. There are query parameters, right? So we saw one of them, and you can add restrictions and all sorts of things on those query parameters. There are headers that you can capture, both inbound headers and outbound headers. You can indicate different responses for different status codes. And you can actually include not only the schema, but also examples, right? So examples are really good for making it readable. They're also really good for mocking services. So if you're going to mock this API, and you've already got examples, your mocking service should spit back those examples. So those are kind of basic building blocks of a RAML API. Okay. Let's see some of those patterns, right? So let's open them up. So various resource types. First, resource types can inherit from other resource types. So we put in a very simple kind of inheritance. So you can define all the things that are common to your API in a base type, and then you can define something like a collection, which in this case has a get and a post. And we want our collections to be paged. We'll define that in a moment. And one of the cool things is you can actually pass parameters to these resource types. So you can tell it a collection of what, and that can be a parameter that you apply inside of your API. All this stuff, by the way, you can find online. So I'll go through it a little bit quickly. One of the interesting things, as I said before, is that it's all externalizable. So you can take these, once you've nailed down your pattern, and publish it somewhere. Right? So we saw inheritance. We saw you can pull in the traits, how you can parameterize resource types. What are these traits? So here's a couple of traits. Paged, right? For me, paged is defined by start and pages. But you might define some other trait, or you might define page to be something different. You can go ahead and encode that in here. And here we've defined a collection of books that is both paged and searchable. Pretty easy to express these kinds of concepts. Okay. We did have, it's a slightly different model, so this is more of a mix-in model than an inheritance type model. When you actually start to build a lot of APIs, you kind of start to get a sense of in which case is it okay to take on the complexity of inheritance, and in which case do you want to make the mix-ins explicit right there in your API definition. This seemed to be the right mix of these things. Okay, schemas. So it is very important to capture the structure of the data that's going in and out of your API. We support XML schemas, JSON schemas, I think, in my opinion, we haven't said the last word on this. We haven't actually added that much to kind of the body of knowledge out there, and most people don't use JSON schema, so there must be better ways of actually capturing the data, and I think we're going to need to iterate that a little bit more and probably expand the support for something other than JSON schema inside here. What is kind of cool is not just the support for these, but the ability to embed examples inside. That's actually really important. Okay, the last thing is people kind of forget, but there is this just simple name-value pairs of form parameters. Those are actually extremely common in a lot of APIs, and they're really good if what you have is pretty simple data structures. So feel free to use those as well. Okay. Now, let's give a little demo of actually designing an API. So one of the cool things about coming up with a simple structure is that you can actually design APIs in real time. And let's go do that. Okay, so one of the things that I want to show you is some tooling that we've built. And the interesting news about this tooling is that tomorrow morning, I think it's 7 a.m., we're going to actually open source this tooling, make it freely available, effectively contributing it to the RAML community. So not only is there a spec out there, but now there'll start to be a bunch of tooling, and there's other people working on open source tooling as well. So hopefully there'll be a little bit of community generated around this to make sort of the things with RAML a lot easier. Okay, so I've got an in-browser editor running here, and I'm going to start to type out my interface. So for this example, I've chosen to create a service that serves out world music. Okay, so I'm going to call this my world music API. And on this API, I'm going to define some simple resources. So let's say that I'm serving out a bunch of songs. I'm going to create a songs collection. And what can I do with a songs collection? I can get the list of songs, and I can create a new song. Now what you'll see here at the bottom is we've got this construct called the shelf. It kind of prompts you along until you're kind of familiar with how to type out RAML. And basically, if you know REST, you kind of know what's supposed to go next. But for people who are just learning, this little thing helps. Okay, what can I do with a collection? That's pretty much it. Some people put update semantics into their collection, other people don't. I'm going to add a way to get to individual songs. And what can I do with an individual song? I can get it. I can update it. You can use put or patch or both. Let me do both. And I can delete. Right? So I've typed a few lines, and I've got a fully working API, or at least a fully defined API. If you go here on the right, there's a little embedded console that allows you to see all the pieces of the API that I've actually defined. And in the updated version of this console, there's actually a try it button. And we're working on a mocking service, so just as soon as you've typed out your API, you can actually make calls against the API, because it's pretty well defined. Now, I haven't given it a lot of structure, but it's already working. So I've got the delete, I've got the patch, I've got the parameters that are already in there. Let me go ahead and add a parameter here. Let's see. Let me add a query parameter. I'm going to call it genre. And the description of this thing is going to be filter by genre. And over here on the right, I see that I've got genre. It's a string. I can filter by genre, and I can keep typing out this API, and I can bring my stakeholders in, the people who are going to build the mobile app, to actually play these songs and say, does this work for you? Would you like some things different? Iterate really, really quickly. So it's a pretty cool way to iterate. But as my API gets big, I want to start to capture some patterns. So let me show you some patterns that I've captured, and then I'm going to rebuild the same API. So here we've got these schemas that we saw before. Here's a schema for a song. It's got a title, it's got an artist itself has a, who knows, right? You can make this stuff up all the time. It's kind of cool to be able to kind of model in real time. So here are my schemas. Here are my resource type. I've got a base, I've got a collection, just like we saw before. I've got a parameter called schema. And in this particular case, I've decided my collections will be paged. Okay, and what are my traits? I'll open this up. Here's a paged one. Again, it's start. Let's make a little change so you see this thing is actually live. Here's the number of pages. Here's what secured means for me, that I'm expecting you to submit an authorization header, that a 401 comes back if you failed. Okay, so with those in mind, let me go and create that same interface we had before. So here's the collection of songs, and instead of typing everything out, for every collection, I can just say that the type is a collection, and I'm going to pass it a parameter, schema, which is song, right? Because I defined that up above. Okay, and I'm going to secure it. And then I'm going to add an individual resource. And the type, in this case, is a member. And again, I'm going to pass it a parameter. The schema is exactly the same one. And I'm going to secure this one as well. I don't need to indicate that the collection is page because that was already built into the resource type. And here in 6 lines of API definition, I've got a full CRUD API that's relatively powerful. For example, on a get, I know that my response is going to have this schema. On the whole collection, I can see that I've got some parameters that I can use for paging. And you can see how as you build out a library of these patterns, you're going to be able to define your APIs pretty quickly and pretty consistently over and over again. And to show you here another little example where we actually use the power of YAML itself. Let's say I've got a collection of artists and a collection of songs. But I'd also like to know the artists on a given song. So I can put a little reference to this thing. And I can go and define a collection of artists on a song, which is just the pointer to the artist. And I've just created this whole different API. Again, very, very few lines of code to capture these patterns. You already have these patterns in your head. You might as well type very little in order to actually point to those patterns and use them again and again. Okay, so that's the flavor of RAML. To get back a little bit to the presentation. So we saw how we used RAML in order to design some APIs. It's a design tool. The output of that is a file or multiple files. You can take that with you. It's completely portable. You can check it into your source control. It is your API. It's the contract that we were talking about all this time. There's a work group that we formed. It's called RAML.org. We're not calling it a working group because what we don't want to do is sit for 3 years on the standards committee and go and iterate through every piece of this. So what we really want to do is make it very practical. We've got a work group of companies. You're welcome to submit your suggestions to this. We'll try to be very quick and iterate through and kind of round out those little pieces that aren't quite done yet and make sure that it's actually applicable in the real world. So feel free to go to raml.org, take a look at this stuff. What we're open sourcing is going to be available there starting tomorrow morning, and there's other people building more tools. So stay tuned for more and more stuff. What kind of stuff? Here's just a short checklist that I kind of reeled off. One is a bunch of tooling that's not only available for download, but actually is hosted as well. So we're going to host it in an API hub, but you're free to go and grab those tools and host it on your internal website or wherever it is that you want to take it. We are slowly implementing more and more APIs in RAML, and we're talking to a lot of other companies that are also encoding their own APIs in RAML. Converters. So if you happen to already use some format, we are working, or we would love to have you work on converters from this format to that format. And yeah, it's okay to actually convert RAML to other formats as well. That's fine. We will even supply you the JavaScript parser. We're working on a Java parser as well that can make that a lot easier for you. Okay. Client generators, right? So I'll actually show you one in a second. But it's really cool to be able to point at a RAML spec and automatically generate a client, effectively an SDK, for that API. Server generators or server frameworks. Lots of ways of doing this. There is one particular one that our engineering team has built, and that's if you want, remember our original premise is to help our customers actually publish APIs. So an API basically consists on the top of this kind of interface, and on the bottom, a bunch of work to go and pull all the data together to actually provide that API. Well, MuleSoft is all about pulling data together, so we've got something called API Kit that helps you actually implement RAML-defined APIs on top of whatever systems Mule can talk to, which is pretty much anything out there. But we're also working on Node.js. In fact, there'll be a presentation here at 5 o'clock to show you some more of these tools that were put together, and one of those will be on Node.js. Again, everybody's invited to contribute more and more of these things. Testing frameworks, right? So once you know the API, it is the ultimate testing surface. You should be able to quickly generate a lot of automated tests. So it's, there's a lot of demand now that we're starting to see for testing frameworks for these things. And a mocking service, right? So we're going to build one, but it'd be great to have other competitors out there building more of these mocking services, because the faster you can mock an API, the easier it is to actually validate your designs. Okay, there'll be lots of other ideas, I'm sure. And the other thing is RAML will evolve, right? So as a spec, we don't want it to evolve too fast because people should be able to point to a given spec and build on top of it. But there's a few areas that I don't think we've solved quite right yet. And so we'll be iterating. Right now, RAML is version 0.8 to indicate it's certainly not a done deal, even at the 1.0 level. Okay. In the words of a conference that I guess happened a little bit earlier this morning, one more thing to show you. So we talked about user engagement. And so far, we're engaging users on the interface itself. What if people don't want to read the interface and they don't want to read documentation and they still want to use APIs? So we can use the RAML spec to do something that, for me, has been a real pain. In various places where I've worked before, and I see I have at least one of my former colleagues here who've seen me go through this pain. Whenever you go and you integrate an API, you go and you make a call to the API. You get back some data. You open up a new tab. You take that data. You paste it into the new tab, where you go and you make another API call, and you take that and you open up a third tab and a fourth tab and a sixth tab, because guess what? Your use case is more than one API call, and they're all kind of chained to each other. So that's a pain. And then how do you share that, and how do you recreate that? So we created something called a notebook to help you capture that kind of thing. This notebook is also going to be made available tomorrow. So what can you do with this notebook? It's a JavaScript notebook. And basically, if you've got a RAML API, if you've got an API that's described by RAML, we can help you actually play with that API. So all of my APIs are hosted in this particular funny URL. So I'm just going to remember that. And now I'm going to do this. I'm going to create a client called music for that service that we did before. That service obviously is already running somewhere. And the location of the RAML file is going to be /music/api.raml. Okay, so all I have to do is I actually point it to the RAML file, and it automatically creates a client. How do I know it's a client for that service? Watch this. So I can go and get all the songs, and I can actually get the ones by this genre. Let's say in this case, I'm going to choose, I don't know, reggae. So I'm going to go and grab all of those. And I see that I come back in the body with 5 different objects. I open up the first one. Okay, looks like a reggae song. All right, so now I'm going to actually save that song. My song equals. And I can run that API again, or I can just go to $2. And I'm going to do .body, which gets me all those songs, and I'm going to get the first one. Okay, so here is the result of that first API call. And now I'm going to do something with it. So let me go and post it somewhere. So we use a service called Yammer. And so I'm going to go and create an API client called Yammer. And again, I need to just point it to where the RAML file is, /yammer/api.raml. And it goes out and reads it, auto-generates a little client for it. Now, to be completely honest, this isn't actually going to post it to Yammer, so it's sort of a simulation of what Yammer would do, but OAuth 2 is actually built here, so I could actually finish this out. And I haven't read the documentation for Yammer, but what I can do is actually just go with autocomplete here. I'm going to use my own user ID, and I'm going to go to the blogs collection, and I'm going to post a message that says, I like plus my song.title. Okay, so that's my message, and I'm going to look at the body that comes back from that. Great, so it went and posted that on my Yammer. And this is a pretty cool use case, so I'm going to go and document this a little bit. So let me put a little bit of documentation here. I'm going to put a comment cell. I'm going to say mash it up with Yammer. Great, so I've got the notebook, and now that it's working, I can actually just save the whole thing. In fact, it's been saving all this time. I'll just give it a name. So I'll call this the Yammer example. Okay, and with this, I can just send this URL to anyone, and when they go and refresh this page, they'll get a notebook that has all of that data in it, and they can just hit the play button, and they can just go and recreate exactly that use case. Change the parameters. Let's say that I didn't like reggae, I like rock. Put rock in here and run that. And if I look at my song this time, got a different song, and so on and so forth. So I can actually play with this thing and save the use cases that I want. And one of the things that's just kind of cool, because we're into this portability and we don't want to reinvent kind of stuff that's already out there, is all this notebook, even though it was made available by RAML, is actually encoded as Markdown. So if you actually just look at the source, the whole thing is Markdown. In fact, just to kind of prove that to you, I'm going to grab the ID here. I'm going to go to GitHub, paste that ID in, and you'll notice that it actually really is saved. So all we're doing here is we're creating little gists in Markdown with fenced code blocks, wrapping a notebook around them, and using that in order to make it easier for you to engage your users with APIs. So that's pretty much all I have. There'll be a lot more stuff coming tomorrow morning. Thank you. Do we have time for questions? I think I've got till 2:30. Any questions? Yeah.
RESTful does create you might have a converter for Swagger, for example, right?
Mm-hmm.
So which companies actually adopt it? So for example, IPG, Meshray, those companies, they use RESTful internally?
No, we would love for them to do that. They have their own formats. We've actually invited a couple of them to join RAML because we just think it's a good kind of common ground to share across. So we'll see if they actually end up doing it. So far, our push is really on enterprises that need to actually create APIs, make sure this is really working for them. So there's a bunch of enterprises that are implementing their own APIs inside, using RAML Designer and coding them in RAML, checking them into their source code, implementing it however it is that they want to do it.
If you think about a development process, for example, you define your API before you actually write the API, right? Is there any tool that would help validate if your API is actually following what is defined in RESTful?
Yeah, so there's just starting to be some. API Kit, which is the tool for MuleSoft that I mentioned before, actually does that validation. But we're hoping to actually get a lot of other people to start creating that. As part of the RAML testing tools themselves, one of the kind of patterns for that is to have your server, right, that's actually gone and implemented that API, then generate a RAML file of what it actually implemented, and you just diff the files, and you see whether the RAML that you defined and the RAML that the server is emitting are actually the same thing.
Thank you.
Yeah. Other questions? Yeah.
Is there any connectivity with Thrift?
Is there any connectivity with Thrift?
Or
Yeah. So we've been talking to several people who have various kind of server-side frameworks, JavaScript frameworks, and people who have looked at other or have considered IDL. So I showed Google Docs here. I think Thrift is not something that I've looked at in some detail, so I probably need to go and do that. Yeah, but I don't think I have any more details. With Google Docs, it actually turned out pretty interesting. If you just have flat RAML files without any patterns, it pretty much matches one-to-one. So the conversion between them is pretty straightforward. What Google Docs, Discovery Docs doesn't have is this notion of capturing patterns. And I'm not actually familiar enough with Thrift to know whether it has that or not. Yeah?
So the notebook, you showed us where it created a gist. Is there any way to have all this behind a corporate firewall where they have an enterprise edition of GitHub?
Yep.
Have it push to that instead?
Yeah, absolutely. So first of all, a notebook is free open source software. You can grab it, customize it as you wish. But it's actually built with an extension structure in place. So you can replace the persistent framework with whatever you want. The one that it comes with by default is a GitHub one. And so basically all you have to do is just point it to your internal GitHub repo, and it will save there automatically. Other questions? Yeah.
How far along is the API hub you mentioned?
So API Hub actually exists. It's been out there for a while. What we haven't done yet is to integrate RAML into it. So that's coming tomorrow morning. And then on API Hub, there are, I don't know, 13,000 or so APIs on there. The vast majority are not yet documented in any way because their providers have not actually documented them. So we're starting to crunch through them and actually document APIs. The other thing you can do on API Hub, again, starting tomorrow morning, is create your own notebooks. And then there'll be a collaborative layer for actually sharing that and going through that design cycle with other people.
And have you been in any talks about having, again, behind the firewall version of, say, API Hub for for all the microservices?
We've not. We've kind of said for now we're going to concentrate on cloud and hosted, just to allow us to kind of move really fast rather than pin ourselves down on sort of specific implementations. But again, the tooling, at least the RAML parts of it, are available for you to go and embed yourself. Okay, anything else? All right, thanks again.